Okay, so we're going to work on the big idea from section 16.5 in your book. And the big idea is we're getting conditional probability. So knowing an extra thing, we're going to get it from a tree. And the first thing we really need to do is look at some notation. And so this is real probability notation. This may be new for you guys. The way you read that is x prime. And so math people use that prime notation for a whole bunch of different things. If you take calculus next year, it means derivative. But when you're talking about probability, this means the complement of x. It means basically not x. So if I told you that the probability of x is 0.3, then you know the chance of x not happening would be 0.7. Okay, now let's look at the next clue. Okay, so this says you want the chance of y happening, but you know that x happens. So you know you're right here. Okay, you know that x has happened. And the chance of y happening is 0.6, which means the chance that y didn't happen, or y prime, is 0.4. And this is the same idea, but now we know that x prime happened, and the chance of y happening is 0.2, which means the chance of y not happening is 0.8. And so if I go and grab all those numbers, you check my arithmetic. You know, I'm a dork with that sometimes. This is 0.18 to come down this branch. This was 0.12. This was 0.14. And this was 0.56. Okay, so now we're going to find all these probabilities. Okay, the chance of x prime happening, we put that in our thing. That's 0.7. The chance of y prime happening, we actually had two different places it could happen at, so we have to add those together. 0.12 plus 0.56, which is 0.68. The chance that x prime happened and y prime happened means we come down one branch. X prime happened and y prime happened. So that's 0.56. And the chance that x happened and y prime happened, that's 0.12. And so those are ideas we've done before. Okay, now let's see. Now let's go with the conditional. The chance that y happened knowing that x prime happened means we're at this branch. And if we're at that branch, there's a 0.2 chance we slide down to get y. Okay, now here's the big idea. It's the new one. We want the chances that x prime happened knowing that y prime happened. So we're kind of looking backwards. We kind of have the end results and we know that y prime happened. So I'm going to change my pen color. Get to orange again. Okay, and where are the chances that y prime happened? Okay, so we're going to write, I'm going to do the table first and then I'm going to write the fancy definition. Okay, so if y prime happened, we know that I'm here or I'm here. So I know those are my only two things that could have happened. So I've narrowed my world. And instead of counting, we're going to think about ratios of probabilities. Okay. Okay. And I win. So I know these two things didn't happen. I win if x happened. And so if x happened, I had to have come from this first branch. So that's my winner. My winner is 0.12. And so when x prime happened. Hang on, let me get a raise. Hang on. 2. I can't read my own writing. Oh, it's great. It's x prime. Okay, so let's get a different color pen. Let's get this color purple. Okay, so I win if x prime happened. Out of these two things, and x prime happening is this one. So this is 0.56 in the numerator. And so if I divide this, I get 14 over 17, which is about 0.824. And so the real fancy definition is the probability of x prime happening knowing y prime happened would be, okay, we'll kind of go back to our first thing, get a fraction. You know for sure this have to happen. So you know that that's in your denominator. And your winner is that this happened knowing that this happened. So you need both of them together. So they both have to have happened. Because it has to be one of the choices in the denominator.